Welcome to Mrs. Lee's Chemistry Academy, where no students are left behind. Today we're going to cover limiting reactant and percent yield. The learning objectives are to learn how to perform stoichiometric calculation using mole ratio so that we can determine the amount of product to be formed, and also to decide which is the limiting reactant that would limit the amount of product to be formed. What is the limiting reactant? It is the reactant that's consumed first, and it will limit the amount of product to be made. The calculations would involve first writing a balanced equation. Then we would convert the mass of the reactant to moles of reactant. Now we are going to use the mole ratio from the balanced equation to find moles of product, and then gradually converting it into mass of product. Now, between the two reactants, when we calculate the mass of product from each reactant, the smaller mass of the product will determine the limiting reactant. In other words, the reactant that produces the smaller amount of product is the limiting. The excess reactant is the other reactant that's not totally consumed and will have left over. So how do we calculate it? We go back to the moles of the limiting reactant, and then we will relate it to the moles of the excess reactant using the mole ratio from the balanced equation. And then we will calculate the mass of the excess reactant to be consumed. And then we subtract that from the given mass of the excess reactant, and then we'll find out how many grams will be left over. Another very relevant topic has to do with percent yield, which is equal to actual yield over theoretical yield times 100%. As we all know that in doing an experiment, we never get 100% yield due to some experimental error. The theoretical yield is what we calculate by using the stoichiometric mole ratio from a balanced equation and using limiting reactant concept. The actual yield is what we actually collect by doing the experiment. Here's practice problem number 1. Aluminum hydroxide reacts with sulfuric acid according to the following equation, where 2 moles of aluminum hydroxide will react with 3 moles of sulfuric acid to yield 1 mole of aluminum sulfate and 6 moles of water. What is the limiting reactant when 5.85 grams of aluminum hydroxide reacts with 7.38 grams of sulfuric acid? What is the amount of the product, aluminum sulfate, to be formed? What's the percent yield? We will actually get 7.12 grams of the product. And how many grams of the excess reactant will be left over? Here's the calculation. First, we take the 4.85 grams of aluminum hydroxide, converting into moles. And then we use the mole ratio from the balanced equation, where 1 mole of aluminum sulfate would be formed from 2 moles of aluminum hydroxide. And we got 0.0311 moles of the aluminum sulfate. Then we take the other reactant, 7.38 grams of sulfuric acid, convert it into moles of sulfuric acid, and then convert it into moles of aluminum sulfate using a mole ratio of 1 to 3. Now we get 0.0251 moles of aluminum sulfate. Because the 0.0251 is the smaller mole of the two, that means sulfuric acid is the limiting reactant. So taking the 0.0251 moles of the product, aluminum sulfate, multiplied by the molar mass, we now have 8.61 grams of theoretical yield of the product. Then when we calculate the percent yield, we take the 7.12 grams that we collect from by doing the experiment over the theoretical yield, and we have 82% yield. Now the excess reactant is aluminum hydroxide. How do we determine how much is left over? We take the amount of product, in this case, 0.0251 moles of aluminum sulfate, and going backward, relating it to 2 moles of aluminum hydroxide, the excess reactant, and convert it into grams, and that is 3.92 grams of aluminum hydroxide. Now we can then subtract the 3.92 from the 4.85 grams. We actually have 0.93 grams of the excess reactant left. Problem 2. Here is making use of a particulate drawing where we start out with 6 molecules of nitrogen monoxide NO and 6 molecules of diatomic oxygen. When they react, they combine to form 6 moles of NO2 molecules with 3 moles of oxygen left over. Write a balanced equation and decide which is the limiting reactant. The balanced equation is 2 moles of NO gas reacting with 1 mole of diatomic oxygen gas to form 2 moles of nitrogen dioxide gas. So the mole ratio is 2 to 1 to 2. Now because we have 6 moles of each NO and O2 given, that means 6 moles of NO will react with 3 moles of O2 by the mole ratio. That means the limiting reactant is NO. And therefore 6 moles of NO2 will be formed by taking the 6 mole times the mole ratio of 2 moles of NO2 over 2 moles of NO. Now the excess reactant is the oxygen. Since we start out with 6 moles and we used up 3 moles, so we would have 3 moles left. To sum up what we have learned today, we have learned how to perform stoichiometric calculations, and we learned how to interpret particulate drawing, and making use of this information to determine 1. Which is the limiting reactant, 2. How much of the product is likely to be formed, and 3. How much of the excess reactant will be left over, and finally, what is the percent yield from the experiment. I hope that you find the above lesson useful to you. We would love to hear any comment from you. Any comment will be very helpful to us. And I hope to see you again next time.